Hi, I'm Sean from SpecStory. I'm going to show you the tool we're building. When engineers write code, over here, we can assume they have specific intentions behind all the code they write. But when AI agents generate code, over here, there's a problem. We don't know why the decisions were made and if all the code changes were necessary. To understand the human intent behind AI-generated code, we need a way to trace the changes in the code back to the instructions that were given to the AI. And that's where our tool, Good, comes in. Good shows you which lines of code were written by AI and the complete conversation between the person and the AI agent that led to each change. Here's a simple picture of the usual state of things today when using a tool like Cursor. Hundreds of human and AI interactions are happening in Cursor, but only the final code changes make it into Git commits. Our approach is to pair the Git repository you're using to manage your code base with a shadow Git repository. Your usual Git commits continue to be the intentional checkpoints of your progress, while our SpecStory cursor extension uses the shadow Git repository to automatically microversion all the interactions you have with the AI and each of the resulting code changes that the AI makes in response. What Good can then do is answer the questions, where did this code come from? And what was the intent behind it? And it does this by creating a new kind of hybrid Git blame that leverages both of these Git repositories. So let's get into it. There are 25 unique cases that we're solving for initially, and you can see them here. We have to account for both new manual and AI-originated code, manual and AI edits and deletions of existing code, and code that is already managed in Git, along with code edits that are currently outside of Git in the local workspace. Each of these factors into the answer of where did this code originate from. So let's look at a quick demo. To help build Good, we created a data-driven testing tool that automates running different scenario files. These scenarios simulate our cursor extension and intermix both AI and manual code edits. We can create as many of these scenario files as we need to uncover and exercise all the possible cases. I have the scenario open here that just does the minimal bit of editing needed to expose 6 of the 25 cases we just looked at. When I run the test scenario, you see that the Good correctly identifies the human or AI origin of every line of code in our test scenario. Now, test harnesses are great, but let's also look at an example of Good in action. First, I'll use getBlame to ask about the origin of a particular line of code in a file. I want to know why we created this particular function, and it doesn't seem to be used anywhere. So that's great. I could see the commit that caused this change. And Git will show me the commit message from the author of the change. But I still don't know if this is a change that was handwritten by a human or if it was generated by a coding agent using something like Cursor. And if it was the latter, I still don't know what the person's intent was when the AI wrote this function. How did they prompt the agent, and how did the agent respond? And this isn't limited to reviewing someone else's code. If the person prompting the AI isn't reviewing every line of code as it's generated, they often don't know the origin of each line, and that's where Good comes in to help. If instead we ask Good about the same line of code, we get back an answer that shows us the line we're asking about was in fact generated by an AI agent. We can see what the prompt was and the agent's response that led to the change. Of course, you don't often use getBlame like I'm doing here at the command line. You use it to understand code origination wherever you are working. So in addition to this Good command line tool, we're working on building support into Visual Studio Code and Cursor as a language server. And we're also looking into extending GitHub pull requests with AI code origin explanations in the browser. Our initial focus for Good is on Cursor, and our first delivery will be via our SpecStory cursor extension. The plan is to then extend Good to other IDEs, websites, and tools where people are creating software by expressing their intent to coding agents.